Now, let's see here. Come on. There we go. Now, they do have an entrance ticket, and we're not going to worry about it. Read the charts and graphs, finding information, and so on. Quick check. So this here, this first slide, this is not in your notes. So this here, this graph is not in your note sheet. So I've got a nice laser pointer. This here, A, what are all of these going to be? Because we do have the same name for matrices. In a matrix, the numbers that are going up and down are called the, y'all remember? Columns. They're going to be columns. And going left to right would be the rows. Because every number going up and down is considered to be contained in the column. Left and right is the rows. Well, these here, trial amounts, are just our variables. Now this here is referring specifically to MIN. Well, MIN stands for, so that would be our what? Units. It's telling us what kind of units we would have. And at the very top we do have the title. Now we can have different charts and graphs here. I'm not going to say. Okay. Now we can have different units and different measures that we can talk about here. Of these two here. So we could talk about trials and before or after shaking in these two here, because this really doesn't. Now the next thing we're going to look at is, for some reason, on page 32. I was looking at these here, getting ready for this lesson, and for some reason, 28, 29, 30, 31, and 31 are not included in the slides. They're just in your note sheets. I don't get it, but whatever. Yeah, there's 4 pages that just aren't included in the notes. So I didn't have enough time to put that together so that we could have it. Now, there are 2 types of connections that we can have. One of them is direct and one of them is indirect. This here would be an example of a direct connection. In experiment 2, which of the following samples has the largest moles of solution per liter of solution? Moles per liter is where? Second column, yes, because it has molarity of samples, moles per liter. So which one has the biggest value? EXP.003, because it's the biggest value, yes? This is what we would call a direct connection, because we look straight to the molarity sample, mole per liter. And I look down here, well, 5.12 is the biggest value, so that's the answer. That's all we have to do for this here. So the correct answer for this here is C. In table 1, which of the following values corresponds to the bacterium that has the greatest inhibition under alkaline conditions? So here, when it's saying connection needed, we need a little bit more information. We need to actually look at the passage to see what is it talking about. So the passage says bacteria inhibition by acidic or alkaline environments can affect the efficacy of, no idea, antimicrobial, well, if I had taken a second, antimicrobial treatments. 2 types of bacteria were measured for levels of inhibition when acid and alkalines content varied. The stronger the alkaline or acid, the greater the inhibition of bacteria growth. Well, wait a minute. So the greater the alkaline or acid, the greater inhibition on bacteria growth. So what are we looking at? Which of the following tables corresponds to the bacterium that has the greatest inhibition under alkaline conditions? Well, concentration of acid, concentration of alkaline. Which one has the greatest amount? We have all these here, here, and here. What numbers are we looking at? Probably this second set. And the biggest number is 8.6. 9.1 doesn't show up, does it? No. Zone of inhibition, but 9.1 does show up over here, but this is really connected to the acid. Concentration of alkalines, 8.6. So it's really, we had to do a little bit more looking to see here. Because measurements of the diameter of zone of the inhibition in bacteria cultures regions where there is no bacteria growth were used to determine the growth inhibition. The stronger the alkaline or acid, the greater the inhibition on the bacteria. So this is still right there down at the bottom. The direct question, these questions require you to read information from a figure, chart, or graph. So it's just reading the information straight from a chart, figure, or graph. I will post the homework in Google Classroom if we get there. Indirect question. These questions require you to interpret a figure, chart, or graph using information found in the passage. They require critical thinking to determine the missing connection of information. So the little piece of information that we need. So let's look at the next one. Okay. When comparing sample and fractional distillation, which of the following relative percentages is classified as the purest fraction of toluene? So we do have our percentages here and our amounts. So we're looking at, when considering simple and fractional distillation, which of the following relative percentage is classified as the purest fraction of toluene? Well, is there anything in here telling us what is considered to be pure? Well, it's in the passage, isn't it? The higher relative percentage indicates higher purity. So when we look at this here, so the higher percentage would be 99.27. So the correct answer is D. All right, let's look at the next one. So they didn't provide the table in here for some reason. I still don't know why they didn't do that. Based on table 1, which you do have in your note sheets, what band most likely corresponds to the smallest DNA fragment? So distance traveled. Well, we have 41, 36, 20, and 15. So the top one, band 1, is faint blue, thin band. 2 is pink, thick band. 3 is dark blue, thick band. And 4 is thin or faint blue, thin band. Well, which 2 are thin? 4. 1 and 4. So the correct answer is 1. Or A, band 1. Based on, will most likely correspond to the smallest DNA fragment. It's going to be number 1. Okay, give me 1 second. More specific. Okay, next one. Yep, there we go. Okay, almost there. Yep, distillation. All right, here we go. The information in connection B helps us make sense of how the column labeled traveled refers to DNA fragment size. Based on this, the farther the distance traveled, the smaller the DNA fragment. So the farther the distance traveled, 41 millimeters, belongs to band A. That there, I think, is actual previous knowledge about DNA fragments. So that's one of the few that would be. But most likely, because none of these would actually have just a chart like this here. They would actually have some more information, most likely, given to you. Also, right there, if I'd looked ahead, DNA fragments are short sections of DNA that recognize on an agarose gel band. Thank you. Gel is a band. Smaller fragments travel at a farther distance and faster pace than larger fragments. So that'd have been nice to know. Okay, let's look at the next one. Given figure 1, which of the following pigments migrated the fastest? Well, 1, plant pigments can be separated using a technique called chromatography. And also, the RF value is directly proportional to the speed of migration for varying pigments. So the RF value is the speed that they migrate. So which one migrates the fastest? Beta carotene. Yes? Which is answer choice A. And it's the only one. There's none of them that are at the same amount. So that's all we need here. Questions? Now, that one there is kind of the connection because we needed to make the connection between the fact that one, the RF value does increase faster, so we would have it there. So they gave us the table. Given table 1, which of the following compounds has the lowest boiling point based on molecular mass? Well, it'd be nice to actually know a little bit more about it, yes? So 1A, boiling point is the temperature at which a compound changes phases from a liquid to a gas. And B, boiling points are generally higher for linear organic compounds that have higher molecule weights. So the higher molecular, yes. I'm glad I'm not an English teacher. Molecular weight. So looking back at the table, which one has the higher molecular weight or molecular mass? Yes. Yes. So methylate has the highest at 114.23, but since it has for the lowest, ethylene. But one thing I want to point out, especially with this here, I'm going to struggle with these words all the way through, but did we really need to actually pronounce any of this or know what any of these are? No. And that's one thing they will do, especially on the ACT science portion, to try to trip you all up. They try to throw these big words in to get you all confused. Now, we're going to go on and look at, well, let's do something a little bit different today. I want y'all to look at passage 1, 2, and 3. We will do one of them together, and I will assign one of them for homework, and the third one will be for points. Well, the homework and the other one would be for points. Which one do y'all want to do together? Passage 1, 2, or 3? All right. I'm good with that. 6. Okay. So the homework is going to be problem 6 through 10. So passage 1 is given here. Now, I'm going to look straight at problem number 1. The estimated variance for the unconstrained model of cloud radiation forcing NET-CRF in March was closest to which of the following? Well, NET-CRF. And we're also talking about unconstrained. Is that going to be figures 1, 2, or 3? Right, because figure 1, LWCRF, 2, SWCRF. The only one that actually talks about NET-CRF is figure 3. And then we also talked about unconstrained in March, yes? Unconstrained is the graph or line with the closed dots, and we want to know in March. Unconstrained, yes, thank you. I don't know why I was saying constrained, unconstrained. Yep, it would be 0.74. Unconstrained model, just below 8, so it's going to be 0.74. Okay. Question number 2, based on figure 1 and figure 2, the lowest peak of estimated variance in the unconstrained LWCRF and SWCRF models corresponds to which of the following months? Well, so again, we're talking about unconstrained between figures 1 and 2. Well, in figure 2, that right there is the lowest, which is at May. Well, SWCRF, yes? Well, what are our answer choices? May, September, April, December. Only one with May. Because figure 1's a little bit harder to see which one it is, but it is November, and that is the correct answer. Any questions on 1 or 2? Question number 3. In the figure, the estimated variance in the unconstrained model was about 0.45. Which of the following months? Would be November. All right. Question number 4. If there's no questions on 1 through 3. Question number 4. Based on figure 1, one of the points at which the constrained and unconstrained LWCRF models intersect corresponding to which month? Figure 1. So where do they intersect? So June, yes. September, it looks like that they could be there too. June or September. And let's see what the answer choices are. September. Well, it was either June or September. June was not listed, so we're going with September. And lastly, in Table 1, which cloud types has the greatest effect on cloud radiativity forcing? So we're looking at Table 1. Now, does it give us radiativity? Whatever that word. Greatest effect on radiative force. So most likely we're going to have to look back at the passage. The effect of cloud types on solar radiation can be determined by measuring the cloud radiative forcing, which is the ratio of the radiation energy in a clear sky versus a cloudy sky. Table 1 shows the percentage of clouds based on type as well as their effectiveness of cloud radiative forces. So it's the percentage that they gave us. And said which one has the greatest effect of cloud radiative forces? So we look at this here, we're looking at the cloud amount. So which one has the greatest amount? Cirrus only. So answer choice A. So homework is our 2.42, 6 through 10 all. Yep, it's over there.